This question says, consider the following processes and determine whether they are endothermic or exothermic. So, endothermic means the system is absorbing heat energy, and exothermic means the system is releasing heat energy. And these refer to delta H. And delta H is equal to Q at constant pressure. So essentially there's no work term here, which makes the math easier, if you will. So let's look at this boiling water at its boiling point. So what we have is H2O liquid, right, going to H2O gas. And what you want to ask yourself is, do I have to put heat in? Okay, so endothermic means absorbs heat energy, and exothermic means releases heat energy, or does heat come out when this process happens? To turn water from a liquid into a gas, I have to put heat in. Therefore, this process is going to be endothermic, or said another way, delta H is equal to a positive. For endothermic reactions, delta H is positive. For exothermic reactions, delta H is negative, same as Q. Q is positive when heat is absorbed by the system, and Q is negative when heat is released by the system. Freezing water. So here we have H2O liquid, and we want to turn it into H2O solid. Do we need to take heat away from liquid water to turn it into a solid, or put heat in? We need to take heat away. So if we need to take heat away, that means heat needs to come out of this. Believe it or not, this is actually an exothermic process where delta H is equal to a negative, because liquid water has to release heat energy to turn into a solid, which makes sense. All right, dry ice subliming. Dry ice happens to be carbon dioxide, and subliming, as it says here, is solid to gas. So we have CO2 solid going to CO2 gas. If we want something to turn from a solid to a gas, do we have to put heat in, or does heat need to come out? In order for this process to happen, we have to put heat in, so this is an endothermic process, and delta H is equal to a positive. Candle wax burning. Do not think about when you initially start the fire. Okay, that's basically the activation energy. What you want to think of is the candle is already burning. Is that endothermic? Okay, you have to put heat in to make that happen, or is that exothermic? Heat is coming off. Of course, when a candle is burning, heat is coming off of it. So this is an exothermic process. Delta H is equal to a negative. One common thing that sometimes people think of is, what about lighting the candle? Do not consider lighting the candle, okay? You do have to put heat in to get it started to burning. However, once it's actually burning, when the candle wax is burning, that is an exothermic process. Heat is coming off, and delta H is negative. These things are counterintuitive and absolutely take practice.